Hi there. Today we will discuss prototype design pattern and various subtopics like what is prototype design pattern, when to choose prototype pattern. We will also see code demonstration and issues with clonable interface. Also, we will have a look into interview questions and answer and finally quiz. So let's see what is prototype design pattern. Prototype design pattern is a creation design pattern used to create objects by copying an existing object known as prototype. This pattern is particularly useful when creating new instances of a class is resource intensive or complex, as it can significantly reduce the overhead of object creation. By cloning a prototype, you can dynamically create objects at runtime without relying on extensive subclassing. This provides flexible and efficiency in object creation, especially in scenarios where objects have multiple states or require complex initialization. The prototype pattern also helps in decoupling the client code from specifics of object creation, promoting cleaner and more maintainable code. Now let's see when to choose prototype design pattern. There are various scenarios for this. For example, expensive object creation. When the cost of creating a new instance of a class is high in terms of complexity or resources, cloning an existing object can be more efficient. This is particularly useful when object creation involves complex initialization, heavy computation, or resource-intensive processes. Avoiding subclasses. If the application needs to create objects of multiple types, the prototype pattern can be an alternative to subclassing. Instead of creating a large number of subclasses for different configuration, you can use prototype instance and clone it with the necessary modifications. Object configuration. When objects have a large number of configurations or states, it can be easier to clone a pre-configured prototype than to instantiate and configure a new object from scratch each time. Nextly, we will see a code demonstration. But before that, let's understand what is deep copy and shallow copy. A shallow copy copies the object's primitive fields and references to objects. It does not copy the object that references points to. On the other hand, deep copy copies the object's primitive field and also create new instances of the object that the preferences point to. Let's see an example of this. Let me run the example. Here what we have done, we have created a shallow copy and a deep copy. Shallow copy is nothing but we need to add a code like this. For address and for building, we have implemented clone and created a shallow copy like this. We have overridden clone method and we are just returning the super.clone. On the other hand, deep copy is created like this. We need to have a method like this where we are copying and creating each and every instance of an attribute of that instance. For example, city, street, etc. And then we are returning new building. So these are the ways in which shallow and deep copy are created. Now let's go back to the slides. There are also issues with clonable interface, which we needed to create the shallow or deep copy. Let's see what are those. As we can see that there are shallow copies had some pitfall as well, like the default implementation of clone in object performs a shallow copy. This means only the primitive fields and object references are copied, not the actual objects they reference. This can lead to unintentional sharing of references and bugs if deep copying is intended. Deep copy also has its own complexity. Implementing deep copy requires manual cloning of each mutable field, which is complex and error prone. Developer must ensure that all referenced objects are also clonable and they are cloned properly. To see this, we can again go back to the code and see what our responses are. Here what we are trying to do, we are going to print what is the actual object, what is the shallow copy of it, and what is the deep copied object. So we can see the original object, we are not doing any change here, so we will be getting it like this. Now when we do shallow copy, we'll get exact copy of our original, and deep copy is also similar to that. But when we try to modify it, for example, we are trying to modify these two attributes, city and streets here, then we'll be able to see that the deep copy has changed. Apart from this, we also need to handle checked exception. The clone method throws clone not supported exception. It is a checked exception, and that adds additional boilerplate code and complicates the implementation. Moreover, the clone method is protected in object. So subclasses must explicitly override it and often need to change its visibility to be usable outside the class hierarchy. Let's see that. This is our cloneable interface. It's a marker interface, and our clone is this method, which will come from the object class. So let me go to the object class. So this is our clone method. Now instead of doing this, we should have a custom cloning method. Now let's see an example of the same. Before that, what we will consider a code which is not using cloning or which is not using prototype. And we have a scenario where we need to create a society. In that society, we are having some buildings and some row houses. To create that, we will need to have this kind of structure. We'll be having buildings in which there will be some attributes. We'll be having constructors and its getter setters. Also, we'll have a toString method. In row houses, we'll be having similar kind of implementation where we are having attributes such as square feet and number of rooms. If you want to create a society out of this, these are the steps which we'll have to take. We'll have to create object of building, object of row house, and then we can print them. Let's see how does that works. So we are creating society with 3 buildings and 4 row houses. We can see that these are 3 buildings and 5 row houses are having similar kind of configuration. Like in this building, we are having 25 floors, square feet area of each flat is 2000, and the number of room is 3. Configuration of row houses is a bit different. The square feet is different and number of room is 5. Now prototype pattern helps us to create same type of object, but what we have done here is we have to create each time we have to create new building for every instance of building, and similarly for row houses we had to create new for each row house. To solve this, what we need to do is, let's go to this building. We need to implement prototype. Now, what is prototype? Prototype is just our interface which we are using. So it is a simple interface named prototype, and which is having this kind of structure. It has a clone method, and prototype is the return type of it. When once we implement that, we need to add the method as well. Let me do the same. So what we are doing here is we are returning a new building, and we are returning the number of floors, square feet, and number of room of this class. Similar thing we need to do with row house as well. Now let's again go to our client prototype class. Here what we are trying to do is that we are creating a building, and based on that instance we'll be doing clone, and that will be assigned to our new instance like this. So we are having 3 buildings here, and as the configuration are same, like 25 number of floors, square feet, etc., it will be available to us in other instances as well. Similarly, we are doing for row houses. Here we can see that row houses are cloned as well. Now we are again creating society with the buildings and row houses, but this time we are going to use prototype design pattern. Now let's see what the output do we get. So we can see that we are getting similar kind of output. The first scenario is where we have not used prototype pattern, and we had to create a lot of instances even when the object configuration was same. Here we can see that we have used prototype pattern, and we can see that we have to make less effort for object creation as all of the work was done by clone. Now let me go back to the slides. Now we have to discuss, based on our understanding of the program, what are the various interview questions and answers that can be asked. The first question is, what is prototype design pattern? And explain its purpose. The prototype design pattern is a creational design pattern that enables the creation of new objects by copying an existing object known as the prototype. This pattern is particularly useful when the cost of creating a new instance is expensive, or the instances needed to be created dynamically at runtime. The purpose can be efficiency, which reduces the cost of creation of object by reducing existing instances. It also provides flexibility, which allows dynamic creation of object without relying on complex inheritance structures. Also, decoupling. Decoupling the clients from specific classes of objects it needs to create, promoting greater flexibility in object creation. Second question that can be asked is, when should you use prototype pattern? Also, we can ask that what are some practical scenarios for the same. So as we have seen in our example, we need to use prototype pattern when resource intensive creation is needed, when creating a new instance is expensive in terms of time or computational resources. An example can be initializing a complex object that involves heavy computation, database connection, or file input output operations. Second point is avoiding subclass. When there are many variations of an object, and subclass would lead to an explosion of classes. A practical example of it is a graphical editor where different shapes like circles, squares, etc. can be created by cloning a prototype and then modifying its properties. Third point can be object composition. When objects need to be dynamically composed of other objects at runtime. An example of it can be configurable software modules that needs to be instantiated and customized based on user input or configuration files. Next question can you explain the difference between shallow copy and deep copy in the context of prototype pattern? So as we have seen in our example, in a shallow copy, the cloned object is a new instance, but it shares references to the same object that the original object refers to. This means that changes to the shared object will be reflected in both the original and the cloned object. On the other hand, deep copy, the cloned object is a new instance, and all the objects it references are also recursively cloned. This ensures that the cloned object and the original object are completely independent of each other. Next question can be, what are the potential drawbacks of using prototype pattern? Here we can answer like complex cloning logic. As we have seen in the example, implementing cloning, especially deep cloning, can be complex and error prone. Ensuring that all referenced objects are correctly cloned requires careful consideration. Also, there can be hidden dependencies. Cloning might copy hidden dependencies or internal state that could lead to side effects. Another reason is memory usage. Deep cloning can increase memory usage significantly as it involves creating copies of all referenced objects. Moreover, there can be copying performance. In some cases, there are time and resources required to clone an object, especially deep clones, and it can negate the performance benefits. Now, in the last section, we have a quiz where you need to match questions on the left with corresponding answers on the right. Give it a try and see how many correct answers you can get. Feel free to answer the quiz question in comment section. Your interaction is valued. Thanks.